Today we will discuss an important theorem of steady current, that is Thevenin theorem. First we discuss our statement. In a circuit containing linear ohmic resistances and energy sources, the current flowing through the load resistance is the same as that supplied by a single generator of open circuit voltage Vg and internal resistance Rg. The voltage Vg is the open circuit voltage across the terminals to which the load resistance is connected, and Rg is the resistance of the circuit looking back from these terminals, with all the energy sources replaced by their internal resistances. So now we will draw a circuit to understand the statement. This is nothing but a circuit. There are generated voltage Vp, Ri the battery resistances, and this is the ohmic resistance R1, R2 and R3, and this is the load resistance RL. So we assume the current, let the current flowing through resistance R1 I1 and through the resistance R2 the current is I2. So applying the KCL law, the current through R3 is I1 minus I2 total that is I1 minus I2. This is I1, so subtract I1 minus I2 equals to the current flowing through R3 resistance. So if we apply, let these are the two loop, or loop 1, loop 2. Apply KVL law in loop 1. So what is KVL law? Current voltage drop. What is KVL law? KVL law, Kirchhoff voltage law. It states that the algebraic sum of the voltage drop around a closed path must be zero. So in the direction of the current, this is the supplied voltage Vb, and this voltage drop is V equals to I1 into R1 voltage drop, and their voltage drop R3 into I1 minus I2 equals to Vb. So Vb equals to total voltage drop Ri plus R1 into I1, that is Ri plus R1 into I1 plus R3 into I1 minus I2. So that is voltage drop, total resistance R1 plus Ri, and current is I1. So voltage drop is I1 into Ri plus R1. Similarly, in the resistance R3, voltage drop R3 into I1 minus I2. So applying KVL law, we get Vb plus minus Vb plus Ry plus R1 into I1 plus R3 into I1 minus I2 equals to 0. This is equation 1. Again applying the KVL law in the loop 2. voltage drop R2 plus RL into I2. voltage drop V equals to क्या होता है IR. so voltage drop R2 plus RL into I2. This is the in the direction of current, so does not come the negative signs, while in the case of R3 the direction, this current direction opposes this current direction. This is the assumed current direction. This assumed current direction opposes the current in R3 resistance, so this should be negative. So R3 into I1 minus I2 plus R2 plus RL into I2. So after rearranging equation 1 and 2, this is the equation 1 and equation 2. After rearranging, we get I1, the coefficient of I1 is this and coefficient I2 is this from equation 1, and from equation 2 the coefficient of I1 is R3 and I2 is this. So this is the equation 3 and 4. So solving these equations for the load current I2, for I2 current, use the Kemmer's rule. What is Kemmer's rule? Just in for I2 you just put the coefficient of I1 and I2 and the right hand side, that is here voltage, right hand side coefficient but constant VB and 0, VB and 0, and I1 coefficient, this put this coefficient here, and I1 coefficient minus R3, put this minus R3, divided by coefficient of I1 and coefficient of I2. So this is the simple determinant. After solving this determinant, क्या होता है solving determinant? R1 plus R3 plus Ri into 0 minus of VB R3, this minus minus plus, this is R3 VB. Again in the denominator, R1 plus R3 plus Ri into R2 plus R3 plus RL minus R3 square. Now for simplification, now you multiply this R2 plus R3 into this and R3 into this, R2 plus RL into R2 plus RL into this and R3 into R1 plus R3 plus Ri. So after this R3 will easily eliminated, R3 will be eliminated, R3 square will be eliminated. So this is the I2 current. Simple calculation. Now using Thevenin's theorem, we will determine this I2, that is the current through load resistance. So first for this calculation of I2, you must first find VG, that is the open circuit voltage. This is the open circuit voltage. Remove this RL and calculate the voltage between C and D, that is the open circuit voltage. If you remove this RL, so there will be no flow of current. So simply you calculate the voltage across this point. This voltage should be the open circuit voltage VG. So for calculation of VG, first we calculate the current through this loop. So these three resistance are in series, so equivalent resistance should be Ri plus R1 plus R3, and voltage is Vb, battery voltage, generated voltage. So using Ohm's law, V equals to IR, V equals to IR current should be in R3, I equals to V by R. So I equals to Vb by Ri plus R1 plus R3. The total resistance, and this is the battery voltage. So current in this loop, I equals to this. Now Vg equals to Vg equals to this voltage between this point. So this point, this Vg must be same as the voltage between this point. So what is the voltage? V equals to IR. I is calculated here, Vb by Ri plus Ri plus R3. So V equals to I R3, Vb R3 by Ri plus R1 plus R3. So hence we calculated Vg. Now calculate the resistance Rg. Open. What is Rg? Rg is the resistance of the circuit looking back from these terminals with all the energy sources replaced by their internal resistance. So these circuits should be replaced by these circuits. Just we removed this battery voltage and this load resistance. So simply the Rg between C and D is calculated Ri and R1 is in series. First take R2 is in series with the parallel combination of R1, Ri plus R1 and R3. That is this means R1 and Ri in series. This series combination is in parallel combination with R3. So Ri plus R1 is in series with the parallel combination of parallel with R3. These two resistances in series, these two resistances is in parallel with R3, and total combination is in series with R2. This is the Rg voltage, Rg resistance. So R1 plus Ri and R3 is in parallel. So parallel combination equivalent resistance is R1 R2 by R1 plus R2. This is R3 in one resistance, first resistance, second resistance multiple divided by summation of these two resistance, and Rg is R2 plus this. So we have calculated Rg. Now we connect. So now this complex circuit is now replaced by simple Thevenin circuit. This open circuit voltage Vg and Rg resistance. Now we connect RL between C and D point. C and D point. So IL equals to Vg by Rg plus RL. Using Ohm's law, V equals to IR, V equals to IR. So Vg equals to I, here is IL, R is Rg plus RL. So after rearranging, IL equals to Vg by Rg plus RL. So putting the value of Vg and Rg, we get this equation 8. This is the load current IL. This is same as we had calculated the I2 current. This equation 5 and equation 8, equation 5 and equation 8 agrees, which established Thevenin theorem. Thank you so much.